In this session, we are assuming that we heard explanations related to each interface in the previous session. For those who may have missed it, please refer to the previous lecture. Let's take a look at the different serial protocols. First, regarding the version, I explained it last time, but I will explain it again. In the case of the request, the first and second bytes of the packet are fixed. The values are fixed at A2 and C1 in hexadecimal, and for the version, the third byte should be 14 in decimal, which is 2 in hexadecimal. The data length is 0, so you only need to send these 4 bytes. Once sent, a response byte will come back from Pixy, and in the case of the response byte, the first 2 bytes are fixed. In hexadecimal, for AF, C1, and the response, the third response type byte is 15 in decimal, which is F in hexadecimal, and the data length is 16, which is 10 in hexadecimal. Then, the fifth and sixth bytes are the checksum bytes. In the case of the checksum, it is a WA 16-bit value that is the sum of all the data bytes that come after this checksum, and that 16-bit value is divided into the first and second bytes. You can check this in the checksum, and if there are no issues after verification, the next part is the data passing section. Looking at the data part, the first 2 bytes represent the hardware version, the next 2 bytes represent the firmware version, and the following 2 bytes represent the firmware build number. Up to this point, you can display the information in a general numerical format. From here on, the firmware information is in ASCII format, so you can simply convert it directly into a string format. Next, we will look at requesting the resolution and receiving a response. As I mentioned earlier, the 2 bytes at the beginning of the request are fixed. I will skip this part when explaining later. In the case of the type, the decimal value of 10 indicates that the data length is 1, and then the data follows. You can put any value here. This is just a placeholder in case the manufacturer of Pixy2 decides to use it when updating Pixy2 later. However, it is not currently in use, so you can enter any value you want or simply put 0. If you send 5 bytes, you will receive a response like this. For the response type, the decimal value is 13, and in hexadecimal, it is D. The data length is 4, and please check the checksum. I will only mention the checksum here, and will not bring it up again later. Next, the first 2 bytes represent the frame width, which can have a value ranging from 0 to 510. It is also stated that the frame height can range from 0 to 510. Next, we have the protocol for setting the camera brightness. First, the type is 1716, and in hexadecimal it is 10, with a data length of 1. The next part of the data is for setting the camera brightness value, which you can set between 0 and 250. Next, the response for the camera brightness setting usually involves a repeated response type of 1, similar to the parts that will be discussed later. Here, the response type is decimal, 1, hexadecimal 1, and the data length is 4. Therefore, the result value is transmitted as 4 bytes. So, we determine whether the setting made with these 4 bytes was successful or failed. Next, let's take a look at the protocol for controlling the servo motor. The type is 18 in decimal and 12 in hexadecimal with a data length of 4. The first 2 bytes represent the angle of the fan servo motor, which can be set from 0 to 510. Next, the angle of the tilt servo motor can also be set from 0 to 510 as you desire. Then, when you make a request like this and receive a response, the type will also be 1 and the data length will be 4. You will now check the result with that 32-bit value. Next, let's take a look at the protocol for controlling LEDs. In the case of the LED control protocol, when requesting type 20, the hex value is 14, and the data length is 3. But there is a typo here. It should be 3 now, but it was entered incorrectly. Please input 3, not 4. After that, you can enter each RGB value here, between 0 and 255. This is 3, not 4. Let me say it again. Then, just like when making a request and receiving a response, the type here is 1, and the result value is checked as a 32-bit value, confirming whether it succeeded or failed with 4 bytes. Next, regarding lighting control, the type is 16 inches, which is 22 in hexadecimal, and the data length is 2. I apologize for that. Here it's not 4, but 2. Next, for the first white, we need to decide whether to turn on or off the 2 white LEDs located above the Pixy. Turn off is 0, turn on is 1. Then, regarding the RGB LED at the bottom, when considering all RGB LEDs, you can choose to turn them all on or all off. If you turn them all off, it's 0. If you turn them all on, it's 1. As mentioned here, since the data length is 2, you just need to input 2. Next, the lighting control response will also come with a type of 1, and the data length will be 4, transmitted as a 32-bit value, which you can use to check the results. Next, checking the FPS, frames per second, involves confirming how many frames are being processed per second. In this case, you should send 24 in decimal, 18 in hexadecimal, and a data length of 0, which means you only need to send 4 bytes. Next, the response is now response type 1, 1, with a data length of 4, and then the FPS is sent as a 32-bit value, so you can check how the FPS is. Next, let's look at how to request block information. The block information request is now 32 in hexadecimal for the command, the data length is 2, and then the signature, which I previously explained as the mode in my lecture. You can now specify whether to set a specific mode or signature. If it's 0, it means there is none, and if it's 255, it indicates a mode. This allows you to choose options, such as whether to have no blocks at all, or to set all blocks to 255. To retrieve all blocks, you can specify this. When you make a request like this, the response type for the block information is 33 in decimal and 21 in hexadecimal with a data length of 14. Oh, I apologize. You can enter the decimal value of 14 as a hex value. Just enter 14 as a hex value. So, a value of just 14 will come in as the hexa value. The checksum is followed by the first 2 bytes, which is followed by the first 2 bytes, which represent the signature, then the next byte, which corresponds to the x coordinate of the block center, followed by the next 2 bytes, which represent the y coordinate of the block center, and then the next 2 bytes, which represent the width of the block. Regarding the width, these angles are currently coming in based on a 16-bit standard. Then, the next 2 bytes represent the block height. Next, if this is not a color code, it will be 0, and if it is a color code, it will tell you what the current angle of that color code is. So, once you receive this, you can convert it to signed bytes and then view it. This is actually 16 bits, not a signed byte. I misspoke. You should convert it to a signed 16-bit value and then check it. Then, with -180 and 180, you can determine how the color code angle is set, or if it is 0, you can know that it is not a color code. Next, we have the index, the block index value, and then the frame aging value. Here it indicates how much this particular block was exposed on the frame and how many times it was exposed. In addition to this, there is also a line tracking protocol related to the protocol, as well as a protocol for retrieving the RGB values of specific pixels in video. However, I will skip this part since I don't have the hardware. If anyone is curious, you can check the links provided to see the protocols I just explained, along with the line tracking video protocols. This time, I explained the serial protocol of Pixy2 If I have any additional information to share with you regarding PC2, I will prepare it for the next lecture and convey it to you. Then I will see you next time.